Happy day, everybody. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Please do not forget to like, share, subscribe to my YouTube. Thank you so much and God bless you. Today we are taking a topic in mathematics, and that topic is also related to physics as well as other science subjects too. And the topic is on vector. And then under that vector, the topic we are taking today is called the position vector. The position vector, like I did in my last video, is a vector that describes the location of a given point or the location of an object. So we want to use the concept of position vector to determine the area, this particular area of a triangle. If we are given the vertices of this triangle as well as their respective coordinates, like we have seen now. For this vertex A, the coordinate is A1, A2, A3. A1, A2, A3, they are the components of position vector of points A with respect to the X, Y, Z axis. I'm talking about with respect to the 3D Cartesian coordinate system. So the position vector B is described as the coordinate B1, B2, B3, and the position vector C is described as the coordinate C1, C2, C3. So if we talk about the fact that all these ones are position vector, then that means this the vector for point B is going to be tied to a fixed point. Let me call this point, this fixed point, the origin. So like I said, we want to use the position vector to find the surface area of a triangle given the coordinates of its vertices. So now, since each of these parameters given stand for the position vector of respective vertex of the this particular triangle. Now, the position vector for point B, I want to tie it down to a fixed point O here. So that means if I want to reach point B from this fixed point that I have here, I have to go along this particular sense. And that position vector for point B is given as vector B. The position vector for point A, that means I'm going to tie this point A down to the fixed point here to get its own position vector. So that means I'm going to tie it down. Let me draw this down to this fixed point here. So this is the position vector of point A. I'll write it as a vector A. Now the position vector for point C is that I'm going to tie this the vector that describes the location of point C to this fixed point, and that vector is the position vector of point C. So it's as if I'm moving from this fixed point to point C. So I'll write it as C bar. Each of these are vectors that locate the coordinates here. So now, the next thing I want us to also take note of is that the vector B is represented by this coordinate in a vector form. So I will write B1, B2, B3 as a column vector. B1, B2, and B3 as a column vector. Then also for the point A, the position vector is A1, A2, A3. I'm going to write it in column form as A1, A2, and A3. So the position vector for point C, I'm going to write it as C1, C2, and C3. So our aim is to get each of these sides of the triangle. The triangle that I have here, I need to get the side BA and the side AC and the side CB. For me to get each of the side, I need to get the vector. So it's the magnitude of that each of the vector that will enable me to find the side of this triangle. So like this particular triangle is, I want to move along this to establish the vector for each of the sides. I'm moving in this direction from B to A, then from A to C, then from C back to B. So because I'm moving from one point to the other, each of these vector we have here, they are displacement vector. Displacement, because I'm being displaced from one point to another. So this is a displacement vector, this one is also a displacement vector, and this one is also the displacement vector, which is different from the position vector. Now I'm starting now. Now what do we do? I need to get side BA. For me to move from BA, from this point B to this A, I may likely go along this direction on the triangle. I can go in this direction from B to A. If I don't want to go from B to A along this particular path, I can start here and move downward, then I move upward. As I'm moving downward, I'm moving against the sense of the position vector B. As I'm moving forward, I'm moving towards the sense. So when I'm moving against the sense of the position vector, that position vector becomes negative. So in a nutshell, the vector BA along that triangle, I'm moving from B to A, is moving against vector B. If I'm passing this direction like this up to point A, I'm moving my negative B and positive A, which can be written as vector A minus vector B. So now vector BA now can furtherly be written in terms of the components of each position vector, and the components of each of them, like this position vector A, the components are A1, A2, and A3. So I'll write it in a column vector form. So this vector A is A1, A2, and A3. Then minus, for the position vector B, the component is B1, B2, and B3. So this particular subtraction of this column vector is done based on the corresponding component. Like this one now, I'm subtracting A1 minus B1, then A2 minus B2, then A3 minus B3. So now I already gotten the vector of this side BA, but I'm not interested in getting the vector. I'm interested in getting the side of this triangle. So that means I need to find the magnitude of this vector BA. And you can recall that the magnitude of a vector is the square root of the square, the sum of the square of the component vector. So what I have here now, for me to be able to get the side BA, I'm going to have square root of each of these. That means it's going to be A1 minus B1 square plus A2 minus B2 square plus A3 minus B3 also squared. That will give me the side of this triangle. Now, for me to go from A to C, to get this vector, instead of me going from A to C, I can go from A through this position vector here. Since I'm going against this A, it's going to be negative. Then I'll go towards C. So that means vector, this one I have here is case 1. Then case 2, vector AC, I'm moving from A to C. I'll write it like this. So the movement, instead of me moving from A to C, I'll move from A downward like this, then going to this, I'll still reach C. Since I'm moving against this sense now, this one become negative. So it's going to be minus A. Then since I'm moving along this line to reach point C, it's going to be plus C, which can be written as vector C minus vector A. Then in column form, I can write it as C1, C2, C3 minus A1, A2, A3. So C1, C2, C3 is for this vector. A1, A2, A3 is from this vector based on what have indicated above here. So that's for that. Now, since I'm not interested in the vector, I'm interested in the magnitude. I'll take the magnitude of this vector. So the magnitude of AC, vector AC, is going to be the square root of the difference between these components. Let me write the difference out here. So this one actually means C1 minus A1 Then this one is C2 minus A2. Then the other one is C3 minus A3. So the square of the respective components now, I'll put it under the square root sign. So it's going to be C1 minus A1 square. We say plus C2 minus A2 square. Then plus C3 minus A3 square. Everything under this square root sign. That's for that. Then for the side CB, I'm going to obtain the vector, the displacement vector when I'm moving from C to B. So I'll write case 3. Case 3 now. Case 3. So I'm moving from C to B. So moving from C to B, instead of moving along this line, I will move along this line, then to this line to reach B. So I'm moving against C. So it's going to be minus vector C. Since I'm moving along vector, the sense of this vector B is going to be positive plus vector B. So this one can now be rewritten as a vector B take away vector C. And this vector B, like I have shown here, is a B1, B2, B3. Then minus vector C, like I have shown here, C1, C2, C3. So the difference between the vector now will now be B1 minus C1, B2 minus C2, and B3 minus C3. So like we have here now, I'm not interested in the vector, I'm interested in the side of this particular triangle. So that means the magnitude of vector CB now is going to be square root of the sum of the square of this column vector. So the component written in this column vector form. So it's going to be B2 minus C1, everything squared. This is B2 minus C1 squared. I'll write plus B2 minus C2, everything squared. Then square root of, then I'll write plus again. That's a B3 minus C3 square. So that will give me the side of this particular triangle. Now, since I've gotten the side, the formula for the area of the triangle, this triangle is given as half AB sine theta. What I mean by half AB sine theta is that half of two sides, then sine angle between the two sides. So if I take any two sides here, let me say I'm taking side AB and BC. The angle between them, the sine of that angle, times half of the product of this side will enable me to get the area of the triangle. So this is more or less the fundamental procedure in solving a problem that require getting the area of a triangle given the coordinates of the vertices. So we need to solve a problem now. Let me say we are given this problem. The question says the position vector of the position vectors of point A, B, and C of a triangle are as given below. Point A, the position vector of point A is 8, 4, minus 3. Point B is 6, 3, minus 4. And then point C is 7, 5, minus 5. Calculate the surface area of the triangle. So each of these points form what is called the vertex of the triangle. So if I put my triangle in this format, I write my A, and I write my B, then I write my A, then I write my C. So the coordinates of A, based on the question given to us, is 8, 4,